Hello, Mr. Brown.
How are you doing?
I'm good.
Good.
This is a 30-minute session, right?
What's that?
This is the 30-minute session, right?
Yes.
Okay.
I think we left off with inverse functions.
Yeah.
So shall we pick up with proportional relationships?
Sure.
Let's talk in general about this. First of all, if I say something varies, if I say x varies with y, it means that. In other words, I always have to insert a k.
Okay.
If I say x varies inversely with y, like that. K is always in the numerator. Don't forget that. If I say that x varies jointly with y and z, means that. Okay?
Uh-huh.
Now, varies means the same thing as is directly. Is directly proportional means varies directly. This is varies directly, this is varies inversely, and this is varies jointly. Jointly and directly are really the same thing.
It's a really loud noise.
What's that?
It's a really loud noise whenever you talk.
Yeah, I hear that. Let me call you on the phone. You have a phone you can set on speakerphone?
Yeah.
Let me call you and we can get rid of that.
Stop. It stopped, I think.
I think it stopped also, but that's not to say it won't come back. Let's try it.
Yeah.
I have this with a couple of students, and it's always solvable by going to speakerphone.
Okay.
I'm dialing now. Are you answering?
Yep.
Put it on speaker. Yeah, see, that eliminates a lot of it. Now, there's a feedback issue. You've got to go into GoToMeeting and turn it on to use phone, not computer audio. You know how to do that? Go to your GoToMeeting screen, go up to audio. If you click on audio, you'll have two choices. Use computer audio or phone call. At this point, you want to do phone call. There. Now we won't have any interference. Okay? Everything sound okay to you? Okay, cool. And you're not sitting there with the phone up to your ear? Okay, cool. All right, so in this problem, they're saying the amount of money a pepper costs is directly proportional to its weight. So let's say the cost is directly proportional to its weight. What goes on the right side of that equation?
If the cost is directly proportional to its weight, then it's W.
KW.
Yeah.
Okay? And the first step to these problems is always solving for K. Notice they're going to give us enough information that allows us to solve for K. They say if a 2-pound pepper costs $4, well, that allows me to write this. Now you know K is 2, right? So now the equation becomes the cost is 2 times the weight. So that is the specific equation. And they say, well, what would an apple that cost $3 weigh? Well, now I can plug in 3 for the cost, solve for the weight, £1.50. And that's the way all of these problems work. You have to solve for K as your first step, which means you have to include it in your general equation. Now, this is the general equation. This is the specific equation for peppers only. In other words, bananas would not follow this. Bananas would have a different K. Apples would have a different K. So every situation has its own specific K. So you always...
But why is it that it gives a 2-pound pepper and then it gives an apple?
Yeah, that's a typo.
Yeah.
Seriously, it is. There's no way to answer this problem the way they've stated it, because they haven't told us what the K is for an apple.
Yeah.
And they haven't given us any information. The only K that we can calculate is for peppers.
What if they were jointly related?
Well, if they were jointly related, then the equation would be this. The weight of a pepper and the weight of an apple. But the problem is they give us a 2-pound pepper costs $4, so I would not be able to determine much of anything other than that's 2 and that's still the weight of an apple. I got 2 variables here I can't solve for. That's why this is a typo, is because they absolutely have not given us enough information to solve for an apple. In fact, the proper solution here is no solution. We don't know. Peppers, not unless peppers and apples cost the same thing or have the same K.
Yeah, maybe it was a trick question.
I don't think so. I think it was a typo.
Uh-huh.
This word was meant to be pepper. Then at least it would make some sense and it would be a problem worthy of working through. Let's look at this one. See if they continue to make typos. So if work, this is a little different in that they don't introduce the concept of K, but that's okay. This is a true physics equation. Work equals the force times the distance. And by that, they mean if you take a 100-pound force, say a 100-pound weight, and you lift it up 10 feet, you've done 1,000 foot-pounds of work. And just so you know, you can struggle lifting up that 100 pounds as hard as you want. If you do not move it, you've done 0 work. It has nothing to do with the effort. It has only to do with the weight, which is measured in force, and the distance that you move it. That's what work is. In other words, I can go and try to lift up a 300-pound weight and struggle for a half an hour and wear myself out, and if I don't move it 1 inch, I've done no work. Okay? So, if this is a true statement, if the distance halves, what happens to the amount of work done when the force remains the same? Does it double? Does it half? Or does it stay the same? Yeah. In other words, if the force stays the same and the distance is in half, then the work is half. In In other words, this work is 1/2 of the other work, of the initial work. So yeah, the work goes in half. And they didn't give us a problem that required us to deal with K. Although that's surprising. Most of the time you will. The solution to those direct relationships are solving for K, always. Alright, here we're going to simplify. When you're talking about simplifying, think factoring. Always. Always think factoring. How's the top factor? Dominic, there's few things you're going to have to do in math more important than factoring. I could spend a half an hour teaching you how to factor, but it might be a little late for that. We don't have a half hour to learn factoring. I'm just telling you that you're not getting through this test without having to do a lot of factoring. Okay? The first thing to do is split up the x's. Second thing, determine the signs. Both signs have to be positive. That's the only way you could produce a positive 9. And now you want factors of 9 that add to 6. So that's the way you factor the top.
Okay.
Now the bottom is difference of perfect squares. How do you factor difference of perfect squares? It's another factoring type problem.
Minus something 3 again.
X minus 3 times x plus 3.
Oh yeah, because okay.
Yeah, if you multiply these two together, your middle terms will cancel one another out, and you'll be only looking at the end terms, which are x squared minus 9.
So that's the answer?
No. Notice now what we can do. We can cross that out with that. They're both x plus 3. So the answer is x plus 3 over x minus 3. That's the answer.
That's actually pretty simple.
It is, but you got to be able to factor. You really got to be able to factor. If you cannot factor, then we should definitely spend some time working on factoring. Like I said, I cannot think of anything that's going to be more important for you on that test than being able to factor. As far as that goes, if I had a brand new algebra student and they said, what's the most important skill I can learn, it would be factoring. Let's try another one.
Okay.
Again, this doesn't necessarily look like a factoring problem, but it is. First of all, if we were to multiply numerators, we'd have an x cubed. Immediately you know that's not going to be right. They haven't taught you much about x cubes. So there must be a factoring that we can do here where I can cross out something. Well, what's the bottom of this? How do I factor that? What's the very first thing you look for when you factor?
X. You know what I
The greatest,
tutoring.
greatest common factor. What's the greatest common factor out of the expression 3x plus 9?
3. Wait. Yeah. Wait.
Leaving?
Yeah.
What's left over?
9. X. Yeah, X.
Not just x. X plus 3. Remember that this times that has to equal what you started with. The secret to math is to always be checking. when you factor something, always in your brain, multiply it back together again. Did I get what I started with? And the answer is yes. I get 3x plus 9. Okay, now when I multiply that by the other term, I got an x plus 3 up there, which I can cancel. In other words, that cancels with that. Also, what's x squared divided by x?
X.
So the answer is that. In other words, it simplifies down rather nicely. And it would be, if you were to multiply that by that and that by that, it would make the problem 10 times harder. Because then you'd have to go back the other way. In other words, it's rare that the solution lies in multiplying these things out. The solution almost always lies in factoring. And that's the first thought in your head that you should have when you're doing these, is, can I factor it? Number 3. It's not a factoring problem because I can't see anything that I could factor, right? But it's not a factoring problem. They say, what value of x is this thing not defined? Well, what makes something undefined? There's one thing that makes something undefined. And usually it's the only one thing that I can think of. Division by what?
Wait, what?
Division by what?
0.
Yes. You cannot divide by 0. That violates every law of mathematics that they've ever invented. So,
so it's -2.
Yeah, here you go. It's that simple. What causes asymptotes?
What did you say?
What, number 4, write a function that has asymptotes at x equal 4 and x equal -5. What causes asymptotes?
I didn't catch that last part again.
What causes a vertical asymptote? Division by 0.
Oh, yeah.
So, if I said here, let me write this a little differently. I don't need to write it like that. I can write it like this. There's my function. Notice that if x equals 4, I'm dividing by 0. Right? If x equal -5, I'm dividing by 0. Therefore, that function would have vertical asymptotes at x equal 4 and x equal -5.
So is an asymptote like points where it's undefined?
It's, yes, which is points where it's dividing by 0. Now, that's vertical asymptotes. There are also horizontal asymptotes.
Is that this way it's x equals?
That's more complicated. No, horizontal asymptotes, there's 2 or 3 different situations that, let's go through it, because they may ask you about horizontal asymptotes also. If I have this, not only do I have here, let me make it a little simpler. Let me make it -1. Obviously, there's a vertical asymptote at x equal 1, correct? There's also a horizontal asymptote at y equals 0. So this function is hyperbolic. It's going to look like that. But it has both vertical and horizontal asymptotes. Now, this question that they just asked had more to do with vertical asymptotes. But you get horizontal asymptotes. I'll go through it real quick. It's a little harder to memorize, but not really. If the highest degree of x is in the denominator, the horizontal asymptote is always y equals 0. In other words, this would be y equals 0, that would be y equals 0, that would be y equals 0. Do you see what I'm saying when I say the degree in the denominator has to be bigger than the degree in the numerator?
Yeah.
And all three of these, it's bigger there because there is no x in the numerator. It's bigger there because there's no x in the numerator and we have an x squared in the denominator. And it's bigger there because we have an x cubed in the denominator and only an x to the 1 power in the numerator. So whenever the bottom's bigger than the top, horizontal asymptote's always y equals 0. There's only one other situation you need to know. And that's when they're the same. Like that. And everything else matters not. The only thing that matters is the highest degree variable, which is x squared. They're the same here. The highest degree in the numerator is x squared. The highest degree in the denominator is x squared. Therefore, the horizontal asymptote is the ratio of the coefficients.
Okay.
And that's it. That's all you have to know. So let me give you a couple of questions and see if you know it.
Okay, let's try it.
Tell me what the... First of all, give me... Give me the vertical asymptote.
The vertical asymptote?
Mm-hmm.
It would be 1.
Correct. X equal 1.
X equals 1.
Remember, the vertical asymptote is the equation of a line. It's not a point. In other words, if I'm graphing this thing at 1, at that dotted line, my function can never cross that dotted line.
Yeah.
Now give me the horizontal asymptote.
The horizontal asymptote is y equals 0 because...
No.
Wait. No, if they're the same, then it's 3 over 4.
That's the horizontal asymptote. So if I'm drawing my grid to graph this thing, there's my horizontal and vertical asymptotes. And I know it's hyperbolic in nature. These always are. So I know it's going to look like this. In other words, once I get my grid on there, then all I got to do is draw 2 lines that are asymptotic with my asymptotes.
Does it matter if they're at the top left and bottom right, or the top left and bottom left?
Sometimes. In other words, if I change the signs here, and I put a minus and a plus, not only would it change which quadrant I'm in, clearly it changes the horizontal asymptote. The horizontal asymptote is now at minus 3/4, right? But instead of being in the first and third, it's probably going to be in the second and fourth. And a lot of times that's the only hard thing to determine, is whether you're in the first and third or the second and fourth. And the easy solution is to plug in a value for x and see where you end up with. Well, what if I plugged in 0 for x?
Mr. Cowan, I need just a second. I'm sorry. I gotta go remind my dad about something I promised to remind him. I'll be back in 1 minute.
No problem. Go ahead.
Yeah, I think I shut the water off. Yeah. Sorry about that.
Okay, no problem. So let's say I had a function like that, and I wanted to know, is that in the first and third quadrant or the second and fourth? In other words, it's either this or it's either my green line or my black line.
Yeah.
How can I tell which one?
By obviously by the signs.
No, you can't actually. That's hard to do, believe it or not. I've tried to do it for years, and I don't have another easy method to tell which one. I do have an easy method, and that is to pick a value for x. And the easiest value to pick for x is 0. Right? Well, 0 for x is right there. What is y when x is 0? Based on my function.
When x is 0, y is 5 over -4.
Okay. Which line am I looking at? The green or the black that satisfies that condition?
Would it be like 5 comma -4? Or
No. The answer is y equals, when x equals 0, y equals -5/4. 5 over -4 is the same as -5 over 4, which is the same as -5/4. But the question is, that tells me that when x is 0, y is down here. Gotta be. That line right there is -3/4. So if y is -5/4 when x is 0, then I can't hardly have the black line, can I? In other words, the answer has to be below this horizontal asymptote. So therefore, that tells me, do I have the black line or the green line? I got the green line. That's my answer. If I were to plug this into my calculator, I'm getting the 2 green lines. I'm not getting the 2 black lines. In other words, I'm going to be in the first and third quadrant, not the second and fourth quadrant. And it's not that easy to tell unless you test it. You almost always are in one or the other. You're either in the first and third or the second and fourth. But only by testing a value for x, and you can pick any x you want. I picked the easiest x to evaluate y, which was x of 0. And that allowed me to know that y would be -5/4, which is below this horizontal asymptote. So there's no way the answer could be a black line like that. That's above that horizontal asymptote. So I know it would be the green line. And that's how I do these hyperbolic functions, is by picking a nice, simple, doesn't always have to be 0. Notice I could not pick x equal 1. That's not an allowable value for x. That's a vertical asymptote. There's no way x can ever be 1.
Yeah.
And that's what that means. When you have a vertical asymptote, it means x cannot be that value, ever. It would be undefined, everything. So I'm never going to pick 1, but I can certainly pick 0 for x. And that tells me which curve I'm looking at.
Okay. You want to try one more before we go?
Yeah, we got time for one more here.
Just finish off that one.
Yeah.
Okay. Let's do it.
What's a good first step?
Separate the x's, I guess.
No.
Wait, is this a factoring problem?
Because that's 2/5, which I can turn into tenths rather easily, then my first step is just to get rid of that and put it on the other side. So what does that give me?
Add 2/5 on the left side.
Which gives me that. What happens if I add 2/5 on the right side?
You get 7/10.
Now, whenever you have a fraction equals a fraction, think cross multiply.
So 10.
What cross multiplying really is doing is 2 steps in one. In other words, I'm going to get rid of that denominator by multiplying both sides by 10, and I'm going to get rid of that denominator by multiplying both sides by x plus 3. Well, when you cross multiply, you do both of those steps at once. There's the multiplication by 10. There's the multiplication by x plus 3. And now, man, I got a much, much simpler equation to solve, right?
Yeah.
Compared to this one had nothing but fractions. Fractions are devils when you're trying to solve equations. The first thing you want to do is get rid of them.
Yeah.
Okay. Now, what's the next step?
Distribute.
Go ahead.
So it's 7x plus 21.
Next step.
10x. And then if there's 3, okay, well when I do this in my head, it's like you subtract the 7x, and there's 3x remaining, and then it has to be 21, so you divide the 21 by 3, and then you get 7.
Well, that's the way you should do it, whether you're doing it in your head or on paper.
Well, I was just making sure I wasn't doing it wrong. But
no, you weren't. The primary thing here is you get all of the terms that have a variable in them on one side, and you get all the terms that don't have a variable in them on the other. So in order to do that, I got to subtract 7x.
Yeah. So tomorrow is our hour session, right?
Yep. Same.
I'm probably going to be scheduling more. Can I ask what time you usually are awake by, or at least what time you're willing to work by?
Whatever time you want, especially being 2 hours later. I can do 9 a.m., which is 11 a.m. your time. I can even do earlier.
Yeah, I don't know if I'm going to be doing too much earlier than that, but
okay.
I'll definitely I'll be thinking about it. Tomorrow we have our hour, and I'll probably let you know when I want the next one tomorrow.
That sounds fine.
6.
That's fine.
Or 4 years.
All right, Dominic.
Have a good day.
I will talk to you tomorrow at 4.